Radiation response and factors affecting it. This is a lecture for the first part of the doctorate degree, The Basics of Radiotherapy. In this lecture, we will discuss the factors that affect the radiation response. This includes factors in the tissues itself as radiosensitivity and factors in the radiation and the surroundings. Radiosensitivity means that two identical doses of radiation may not produce an identical response in the tissues. Law of Bergoni and Tribondeau. Radiosensitivity of living tissues varies with maturation and metabolism. Stem cells are more radiosensitive than mature cells. This leads to that younger tissues are more radiosensitive. Even on the level of the whole organism, children are more radiosensitive than adults. When children receive radiation, it brings about a much more profound effect than in the adults. Also, tissues with high metabolic activity have more stem cells. So, for example, bone marrow and hair are much more radiosensitive than other tissues. Physical factors affecting radiation response: linear energy transfer, radiobiologic effectiveness, fractionation, and protraction. Linear energy transfer measures the rate at which energy is transferred from ionizing radiation to tissues. As the radiation travels through a given tissue, energy is deposited. The rate at which energy is deposited is the linear energy transfer. It's measured in kilo-electron volts per micron of track length. Some types of radiation have low lead. They deposit less energy as they travel, like X or gamma rays, and some are high lead, like alpha or beta particles. The ability of radiation to produce a biological response increases as lead increases. Relative biological effectiveness: dose of standard radiation to produce a given effect divided by the dose of test radiation. Standard radiation is taken to be X-rays that are 250 kilo-electron volts, or the cobalt rays, which are 1.17 and 1.33 mega-electron volts. Other types of radiation are compared to these because these are the most used, and they define the relative biological effectiveness of the other radiations. As the lead increases, relative biological effectiveness increases up to very high doses when maybe the tissues are saturated with energy, so the effect starts to slightly decrease. Fractionation: a dose which is delivered over a long period of time is less effective. If the time of radiation is lengthened, higher dose is required to produce the same effect. So fractionation, or dividing the dose into a series of small doses, causes less effect due to intracellular repair and recovery. Routinely, this is used in oncology because although the tumor repairs itself, normal tissues repair so that the body can withstand radiation without organ failure. Protraction: it's reduced dose rate. An example is if 12 grays is delivered over 3 minutes, 4 grays per minute is lethal for the rat. However, 12 grays, if given as 1 gray per hour, the rat survives. This is the same for human beings. Clinical application for this is low dose rate brachytherapy. Biological factors affecting radiosensitivity: oxygen effect, age, recovery, and chemical agents. Oxygen effect. Tissue is more sensitive when irradiated in oxygenated or aerobic state than in anoxic or hypoxic state. Oxygen enhancement ratio is the dose under anoxic conditions divided by the dose under aerobic conditions. For human beings who have anemia may have less effect on the tumor if they're irradiated. We prefer that it would be at least 8 hemoglobin or more to start irradiation. Age. Age of the biological structure affects radiosensitivity. Humans are most sensitive at birth, and sensitivity decreases until maturity. In old age, sensitivity may increase again, but this is unimportant. This graph shows the sensitivity to radiation, and it decreases till the adult life. Recovery. Cells are capable of recovering from radiation damage. At whole body level, recovery is assisted via repopulation by surviving cells. Recovery consists of repair and repopulation. So repair of the damaged cells and repopulation by the surviving cells which divide, these cause the tissues to recover. This process is affected by chemical agents. Chemical agents may increase the radiosensitivity of cells. The examples are halogenated pyrimidines, methotrexate, actinomycin D, and hydroxyurea. These affect the ability of the tissue to repair itself. So they increase the effect of radiation about twice as much. Thank you. These were some factors affecting why the tissues may respond differently to radiation. Thank you.